Preparing for a Python developer interview? You've reached Interview Guide, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What makes Python a dynamically typed and strongly typed language? Python is dynamically typed because variable names do not have fixed types. They reference objects, and the object type is known at runtime. It is strongly typed because Python does not silently mix incompatible types. For example, 5 plus 5 raises a type error instead of converting automatically. This gives flexibility while still protecting correctness. In interviews, I also mention that type hints improve maintainability, but do not change Python's runtime typing behavior. While answering, focus on runtime type binding, object references, strong type enforcement, implicit versus explicit conversion, and how this affects flexibility, readability, and runtime errors in production code. Question 2. Explain the difference between a list, tuple, set, and dictionary in Python. A list is ordered and mutable, so I use it for sequences that change. A tuple is ordered but immutable, useful for fixed records or hashable composite keys. A set stores unique elements and is optimized for membership checks. A dictionary stores key-value pairs and gives fast lookup by key. In modern Python, dictionaries preserve insertion order. My choice depends on access pattern, indexing, uniqueness, immutability, or key-based retrieval. Make sure to cover ordering, mutability, uniqueness, key-value lookup, common operations, time complexity, and when you would choose each structure in real application code. Question 3. What is the global interpreter lock, and how does it affect Python performance? The GIL is a lock in CPython that allows only one thread to execute Python bytecode at a time. It simplifies memory management, but limits true parallelism for CPU-bound multithreaded programs. For I/O-bound tasks like network calls, threads still help because they release the GIL while waiting. For CPU-heavy work, I usually choose multiprocessing, native extensions, NumPy, or distributed workers. The key is matching concurrency strategy to workload type. In your answer, talk about CPython, bytecode execution, thread safety, CPU-bound versus I/O-bound workloads, threading limitations, multiprocessing, async I/O, and practical performance decisions. Question 4. Why are mutable default arguments dangerous in Python functions? Mutable defaults are evaluated once when the function is defined, not every time it is called. So if I write def add item x items equals 0, the same list is reused across calls. That can leak state and create bugs that are hard to trace. The safe pattern is def add item x items none, then create a new list inside the function. Immutable defaults like integers, strings, or none are generally safe. Be sure to mention function definition time, shared object reuse, lists and dictionaries as defaults, unexpected state leakage, and the standard none-based pattern for safe initialization. Question 5. How do decorators work in Python, and where have you used them? A decorator is a callable that takes another function and returns an enhanced function. I use decorators when I want reusable behavior without changing core business logic. For example, a timing decorator can record execution time around any function. Internally, it usually defines a wrapper that calls the original function. I always use functools.wraps to preserve metadata like function name and docstring. Decorators are clean for logging, auth checks, caching, retries, and validation. While answering, cover functions as first-class objects, wrappers, closures, functools.wraps, reusable cross-cutting behavior, and examples like logging, authentication, caching, retries, or timing. Question 6. What is the difference between an iterator and a generator? An iterator is any object that implements iter and next. A generator is a simpler way to create an iterator using yield. The main benefit is lazy evaluation. Values are produced one at a time instead of stored in memory. For example, reading a huge log file line by line is better with a generator than a list. Generators make streaming pipelines cleaner, but once consumed, they must be recreated. Make sure to cover iterable protocol, iter, next, yield, lazy evaluation, memory efficiency, stop iteration, and when generators are preferable for streaming large data. Question 7. How does Python memory management work? Python manages memory automatically. In CPython, each object has a reference count, and when it reaches 0, the object is deallocated. For reference cycles, Python has a cyclic garbage collector. Small objects are handled to internal memory pools for efficiency. The del statement removes a reference, not necessarily the object itself. In production, I watch for lingering globals, caches, closures, and circular references with del, then use profiling tools when memory grows unexpectedly. In your answer, discuss object allocation, reference counting, garbage collection, cyclic references, memory pools, del, weak references, and practical ways to avoid memory leaks. Question 8. What is the difference between shallow copy and deep copy? A shallow copy creates a new outer object, but keeps references to nested objects. A deep copy recursively copies the nested objects too. For a list of lists, shallow copying means changing an inner list affects both copies. I use copy.copy for simple structures and copy.deepcopy when independent nested data is required. Deep copy is safer in some cases, but it can be expensive and may duplicate more data than needed. Be sure to explain object references, nested mutable objects, copy.copy, copy.deepcopy, performance implications, and common bugs caused by accidentally sharing inner data structures. Question 9. How do Python dictionaries achieve fast lookups? Python dictionaries are implemented as hash tables. When I access D key, Python computes the key's hash and uses it to find a slot quickly, usually in constant time. If collisions occur, Python resolves them internally and checks equality to confirm the key. Keys must be hashable, so immutable types like strings and tuples work if their contents are hashable. Since Python 3.7, dictionaries also preserve insertion order, which makes them even more useful. While answering, focus on hash tables, hashable keys, equality checks, average case constant time, collision handling, insertion order, and why mutable objects cannot safely be dictionary keys. Question 10. When would you use multithreading, multiprocessing, or asyncio in Python? I use threading for I/O-bound work when blocking calls are common, like file operations or API requests. I use multiprocessing for CPU-bound tasks because separate processes bypass the GIL and run on multiple cores. I use async I/O when I need high concurrency I/O with many lightweight tasks, such as thousands of network requests. Threads are simpler with existing blocking libraries. Async I/O scales well with async libraries. Make sure to compare I/O-bound and CPU-bound tasks, GIL impact, process overhead, event loops, async await syntax, shared state complexity, and real-world use cases. Question 11. What are context managers, and why are they useful? Context managers guarantee setup and cleanup around a block of code. The classic example is with open file.txt as f, where the file is closed automatically even if an exception occurs. Under the hood, Python calls enter before the block and exit after it. I use context managers for files, database transactions, locks, and temporary configuration changes. They reduce boilerplate and make resource handling safer and more readable. In your answer, cover with statements, resource acquisition and cleanup, enter and exit, exception handling, context lib, and examples like files, locks, transactions, or network connections. Question 12. How does exception handling work in Python, and what are best practices? Python handles exceptions with try, except, else, and finally blocks. I catch specific exceptions, not a broad except, because broad handling can hide bugs. The else block is useful for code that should run only when no exception occurred, and finally is for cleanup. I create custom exceptions when domain errors need clear meaning. In production, I log enough context, avoid swallowing errors silently, and re-raise when the caller should decide recovery. Be sure to mention try, except, else, finally, specific exception types, custom exceptions, avoiding bare except, preserving tracebacks, logging, cleanup, and not hiding programming errors. Question 13. Explain Python's object-oriented features. including inheritance and method resolution order. Python supports classes, inheritance, polymorphism, and encapsulation by convention. Inheritance lets one class reuse or extend another, and super helps call parent behavior. With multiple inheritance, Python uses method resolution order, or MRO, to decide which method runs. It follows the C3 linearization algorithm, visible through class.mro. I prefer composition when relationships become complex, because it reduces fragile inheritance chains and keeps responsibilities easier to test. While answering, discuss classes, instances, encapsulation conventions, inheritance, polymorphism, composition, super, multiple inheritance, MRO, and why composition is often cleaner than deep hierarchies. Question: what is the difference between @static method, @class method, and instance methods? An instance method receives self and works with object-specific state. A class method receives CLS and works with class-level state, often for alternative constructors like from JSON. A static method receives neither self nor CLS. It is just a utility function placed inside a class for logical grouping. I use instance methods for behavior tied to an object, class methods for factory patterns or inheritance-aware creation, and static methods only when the method truly does not need object or class state. Make sure to cover self, CLS, access to instance state, access to class state, alternative constructors, utility methods, inheritance behavior, and clear design intent. Question 15. How do list comprehensions differ from generator expressions? A list comprehension builds the entire list immediately, while a generator expression produces items lazily. If I need all results, indexing, or multiple passes, a list comprehension is convenient. If the data is large or I only need to stream values into sum, any, or a loop, a generator is better. For example, sum xx for x in nums avoids creating an intermediate list. The trade-off is that generators are consumed once. In your answer, compare eager versus lazy evaluation, memory usage, readability, performance, one-time iteration, syntax differences, and appropriate use in transformations, filtering, and streaming pipelines. Question 16. What are type hints in Python, and do they affect runtime behavior? Type hints are annotations that describe expected types for variables, parameters, and return values. They do not enforce types at runtime by default, but tools like MyPy, Pywrite, and IDEs use them to catch issues earlier. I find them valuable in large codebases because they document interfaces and improve refactoring confidence. For runtime validation, I would use libraries like Pydantic. Good type hints should clarify intent without making simple code noisy. Be sure to mention annotations, MyPy or Pywrite, readability, IDE support, gradual typing, optional runtime validation, generics, typedict, protocol, and maintainability in large codebases. Question 17. How would you optimize a slow Python application? I start by measuring, not guessing. I use cprofile, PySpy, line profiler, logs, or APM tools to find the real bottleneck. Then I check algorithmic complexity, database query patterns, network calls, and unnecessary object creation. Often the biggest wins come from better data structures, batching queries, caching, or using NumPy for numeric work. If concurrency helps, I choose threads, asyncio, or processes based on workload. I optimize only where profiling proves impact. While answering, focus on measuring before optimizing, profiling tools, algorithmic complexity, database queries, caching, vectorization, concurrency choices, memory usage, and avoiding premature micro-optimizations. Question 18. How do you structure and package a Python project for maintainability? I structure projects with clear packages, small modules, tests, and explicit dependency management. A modern setup usually uses pyproject.toml with tools like Poetry, Hatch, or pip tools. I keep application logic separate from framework, database, and configuration code, so it is easier to test. Virtual environments prevent dependency conflicts. I also add formatting, linting, type checks, and CI early. Good structure should make onboarding, testing, and deployment predictable. Make sure to cover virtual environments, dependency management, pyproject.toml, package layout, modules, configuration, tests, linters, formatters, CI, and separation of application logic from infrastructure. Question 19. How do you write effective tests for Python code? I write tests around behavior and edge cases, not internal implementation. For unit tests, I use PyTest, because fixtures and parameterization make tests clean. I mock external services like APIs, queues, or email providers, but I avoid over-mocking core logic. Integration tests cover database and service boundaries. Good tests should be deterministic, isolated, and easy to read. Coverage is useful, but meaningful assertions matter more than chasing a percentage. In your answer, talk about unit tests, integration tests, PyTest, fixtures, mocking, parameterization, test isolation, edge cases, coverage quality, CI integration, and testing behavior rather than implementation details. Question 20. How would you build a REST API in Python and keep it production ready? I would choose Fast API for lightweight async APIs, or Django REST Framework when I need Django's batteries-included ecosystem. I define clear routes, validate request and response schemas, and use proper status codes. Authentication, authorization, pagination, rate limiting, logging, and structured error responses are essential for production. Database access should avoid N+1 queries and manage transactions correctly. I also add tests, OpenAPI documentation, health checks, configuration management, and observability before deployment. Be sure to cover framework choice, such as Fast API or Django REST Framework. Routing, validation, authentication, error handling, database access, pagination, logging, testing, documentation, and deployment concerns. If you are still with us, congratulations! You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.